Good morning, students. Today I'm going to teach you Multimedia Information Representation Module 2. Topic is Introduction to Multimedia Information Representation. What is multimedia? The combination of audio, video, text, image. These are the components of the multimedia. Multimedia. Many mediums are integrated together for the transmission of the signal. That is nothing but multimedia communication. How the multimedia information can be represented, how the representation can be done, what are the multimedia components, audio, video, text and image. Sometimes it is graphics. So whenever these informations are going to be transmitted, then it has to be stored and processed, and then it has to be transmitted. If it is stored and processed, in the sense it will be stored in a computer, digital form. In a computer it will be stored. So if it is an analog nature, then it has to be converted into digital nature. Then this information has to be saved as a binary values. Then for the transmission also, the same bits can be used for the transmission as well as the reception, with the encoding and decoding techniques are used. Suppose in case of textual informations, it consists of strings of characters entered at a keyboard. For example, each character is represented by unique combination of fixed number of bits called as code word. The code word is the term which is used here. It is nothing but each character is represented by the unique combination of the fixed number of bits, that is called as code word. So the complete text by string of such code words are integrated, that is generated by the computer. Similarly, the computer generated graphical images are also made up of mix of lines, circles, squares. So each is represented in the form of digital nature. A line is represented by means of start and end coordinates of the relative complete image. Each coordinate is defined in the form of pair of digital values. For example, devices like microphones and many video cameras produce electrical signals whose amplitude varies continuously with the time. The amplitude of the signal at any point indicating the magnitude of the sound wave or image intensity at the instant. So the signal whose amplitude varies continuously with the time is known as analog signal. In order to store and process the signal, a type of media within the computer, it is necessary to convert first any time varying signal into digital form. In addition to that, the signal used to operate the devices such as loudspeaker or for speech signal or audio signal and computer monitors. These are all the examples of the display of digitized images, are also called as analog signals. These digital values representing such media types must be converted back again into the corresponding time varying signal at the output or at the receiving part. So the conversion of analog signal into digital form is carried out using an electrical circuit is called as signal encoder. So conversion of analog signal into digital form is carried out using an electrical circuit is known as signal encoder. It has to be done. How this it has to be done? In the sense, three types are there. One is sampling, quantization, another one is coding. Sampling in the sense the amplitude of the analog signal at repetitive time intervals. Amplitude of the analog signal at repeated time intervals, and then converting the amplitude of each sample into corresponding digital value. First, if it is a sine wave, so only the amplitude of the analog signal at repetitive time intervals, we are taking that value, and corresponding digital value will be given. Similarly, the conversion of stored digitized sample relating to the particular media type into the corresponding time varying analog form is performed by an electric circuit is called as signal decoder. Second step is nothing but quantization. So converting amplitude of each sample into corresponding digital values. Converting the amplitude of each sample into corresponding digital values. In this way, this analog to digital conversion is taking place using sampler, using quantizer and encoders. Similar way, in the decoder can be used in the reception part. So all the media which is associated with the various multimedia applications are stored and processed within the computer in all digital forms. That means the different media types can be easily integrated together and equally important, and the resulting integrated bit stream can be transmitted over the single all digital communication network. So here we are going to study about the different media types represented in the different digital form, and appropriate conversions required for the operations to be used. So here we are going to discuss about the next digitization principle, where we can understand the general principles relating to how analog signals are converted into their digital form. Similar way, digital form to analog form. Thank you. Next, we are going to see about the digitization principle, how the analog signal is converted into digital format. So, a general properties which is relating to any time varying analog signals are like this. This is the analog signals, and this is low frequency component, and this is high frequency component. So the amplitude of signal varies continuously with respect to time. So in addition to that, the mathematical technique called as Fourier analysis is used to show that any time varying analog signal is made up of possibly infinite number of single frequency sinusoidal whose amplitude and phase vary continuously with respect to time and relative to each other. That means the Fourier analysis used to show the any time varying analog signal made up of possibly infinite number of single frequency sinusoidal signals whose amplitude and phase vary continuously with respect to time relative to each other. The highest and lowest frequency components are shown here. This is highest frequency and this is the lowest frequency, and this is the highest frequencies. The range of frequency of the sinusoidal components that make up the signal is called as signal bandwidth. So signal bandwidth in the sense the range of frequency. This is nothing but signal bandwidth. The range of frequencies of the sinusoidal components that make up a signal is called as signal bandwidth. This is related to an audio signal. First, the speech signal is first one is a speech signal. This is the first speech signal, and second one is nothing but for the musical signal produced by the orchestra. So this is nothing but the combination. In terms of speech, human produces sound which are converted into electrical signal using a device called a microphone that are made up of a range of sinusoidal signals varying the frequency between 50 Hz to 10 kHz. The case of music signal, however, the frequency range of signal is wider and varies between 15 Hz to 20 kHz. This is being comparable with the limits of the sensitivity of the ear. Sensitivity of the ear. Ideally, when an analog signal is being transmitted through the network, the bandwidth of the transmission channel, that is the range of frequency of the channel will pass, should be equal to or greater than the bandwidth of the signal. That means an analog signal transmitted through the network, in the sense the bandwidth of the transmission channel required is the range of frequency channel will pass should be equal to or greater than bandwidth of the signal. If the bandwidth of the channel is less than this, then some of the frequencies may be low or high frequency components will be lost. Some are few low and high frequency components will be lost, thereby degrading the quality of the received signal. This is nothing but digitization principle.